Welcome, Peter. It's great to have you on the show. So, how are things?
Yeah, very good, thanks.
Great. Well, thanks again for taking the time to be with us. I want to start with an intro question, mainly for the people that aren't as aware of Rocket Lab, and then we'll get into the detail of some of your technology and your plans for the future. So, for anyone unfamiliar with the company, as I say, what separates Rocket Lab from peers, and how do you currently generate the majority of your revenue?
Yeah, I think most space companies are easily defined as sort of a launch company or a spacecraft or a satellite company. What's unique about Rocket Lab is we're both. We have a raging launch business with our Electron launch vehicle, and a similar in with respect to our satellite and spacecraft division. But what makes us even, I guess, more unique is we don't just build spacecraft; we build, the majority of the components that go into the spacecraft at very very low level details. So, every reaction wheel or solar panel or even solar cell from a wafer we produce. So, really, the best way to think of Rocket Lab is a one-stop shop from spacecraft through to launch and even operations of spacecraft on orbit.
Yeah, fantastic. I think that's a nice introduction. We'll get back to the detail of a lot of that in due course, but perhaps we can just circle back and cover your background and introduce you as a person to the listener. I was reading some of your biography. I think it was on the Rocket Lab website, and it talked about how you've been building rockets for a long time, starting out creating water rockets as a teenager. Around the same time, I think you turbocharged your Mini, which was pretty interesting to hear. I think maybe there's a general theme there of just being interested in rockets, certainly, but combustion more generally. Perhaps you can just talk to us about where you think that came from.
Yeah, you've done your research. So if you look too much further, you'll see rocket bikes and rocket powered scooters and rocket packs. So I would stop your research at this point. Um, but but I've always been fascinated and drawn to really difficult engineering. So the more difficult the engineering problem is, the more I enjoy it, and high degrees of energy and horsepower. So if you combine those two things together, I mean, high amounts of energy and really difficult engineering, you kind of naturally end up building rockets. And so there's the engineering side of it that I really enjoy. There's of course the space side, which I think is hugely captivating. And there's very few things that have such large impacts as the space industry. And then later, of course, is the hobby grew into a business. The business side of it really fascinates me as well.
Yeah, absolutely. And we'll touch on those kind of early business experiences setting up Rocket Lab as the company that we know today. But before we get there, perhaps we can just sort of work through
Sure.
chronologically. I read that your experience spans working with appliances at Fisher and Paykel. That's not a company I was aware of, so perhaps you can give me a bit of detail there. But through to working with some advanced composites for high performance applications as part of a government research institute back in 2003. So I'm just interested, and we speak to a lot of founders on the show as well. Like, how formative were those early experiences?
Oh, tremendously so. And I think, for me personally, I started off my career as a tool making apprentice. So, precision engineering on the tools, and always building rockets in my spare time. But I went through tool making apprenticeship, then went into the design office and did product design, and then production design, where I helped build production lines, and then then into analysis and CFD and a whole bunch of other things. And then, as you pointed out, went to a government research institute and did, advanced composite materials, supporting things like the America's Cup boats and things like that. So really, bleeding edge stuff. And all those things, provide for a great repertoire of kind of engineering knowledge, skills, and experience. So, I'm equally happy working in metallics as I am in composites, and so I was very lucky to have a very broad kind of education in that sense. It's not like I studied just the fraction mechanics of metallics. It's like, I was in the field breaking boats and wind turbines and living real life experiences. So very very lucky to have such a broad upbringing and such a wide range of engineering discipline.
Yeah, yeah, absolutely. I mean, it sounds completely formative. I mean, then to take us to the business experience that you reference, I think you founded Rocket Lab in 2006, launching Atia One in 2009. But kind of, I guess, from an investment perspective, I'm pretty curious about how you launch a rocket startup in New Zealand, obviously where you're from, and how do you go about securing early funding, how you go about forging relationships for a company like that. Talk us through that process.
Yeah, well, I mean, so the original plan was to head over to the States and go and work for NASA or one of the large space contractors. And I went over to the States and did a bit of a rocket pilgrimage. And really, from that trip, I learned two things. One is a foreign national, it's very very difficult to get involved in the US space industry. And two, a lot of the things that I thought were important weren't really being worked on. So I came back and you can when walls are put in front of you, you can choose one of two things: is you turn around and go in a different direction, or just start digging a hole under the wall. So I just started digging a hole under the wall and then created Rocket Lab. And early funding came from sort of local New Zealand investors and tiny amounts of funding, of course. And then later funding, I jumped on a plane and went to Silicon Valley, and I had the mindset of I'll either be run out of town or come home with a check. And in the end, I only actually pitched to three VCs. There was only three VCs that I wanted to work with, but very lucky to come home with a check. But yeah, no, that it's funny now because I look back on all those years and I somewhat feel like an old soul of the industry, because I can remember a time where running around Silicon Valley trying to raise like $5 million for a space company was an absurd thing. And we've seen people raise like $1 billion, and it's crazy to see how far things have moved so quickly.
Yeah, I mean, incredibly so. And that's obviously one of the many reasons we wanted to speak to you. The story from start to finish is fascinating. And I mean, I guess supposed to bring us closer to present day, you're one of the few commercial rocket companies spread across two continents. So we talk about New Zealand, but then obviously you've got your setup in the US as well. You're also operating at scale, which separates you from a few other industry peers that we'll talk to in a second. But how has the company's evolution and that geographic split more particularly changed your role as a CEO and founder?
Well, I mean, we've from day one we've been in global, so it kind of nothing is like I just get on a plane. It is there's nothing new occurred there. So for us, there was zero space industry in New Zealand when we started, so it's not like we had a local market. So it was it was always be global from day one. And quite frankly, the only reason we have any operations in New Zealand at all is because of the Mahia launch site where we launch Electron from, which is the only operational private orbital launch site in the world. It gives us a huge advantage. So yes, so we started off as a New Zealand company. I think 2013 we flipped into being a US entity with a New Zealand subsidiary. But we've been global from day one, and that's just normal.
Great. All right. Well, let's get into the competitive landscape in the industry at large, as I alluded to a moment ago. In terms of the industry's overall evolution, a number of rocket companies exist now, with infinitely more satellite firms, something that we'll speak to, I'm sure, later on. So I just wondered if we should expect increased consolidation as the industry matures. How do you see that panning out between launch and satellite companies?
Well, I mean, let's talk about launch first. I mean, I would say that we were at the beginning of a small launch evolution, and we weren't actually the first. There was Virgin Orbit was I think the first. But tremendous. We were tracking at one point 140 startups in small launch, and we were not picked to be the favorite. I think Virgin Orbit had over $1.2 billion poured into it. And to give your listeners some context, that's 1.1 billion more dollars than we spent getting our first rocket into orbit. So if you're running a book, the odds weren't stacked in our favor. But at Rocket Lab, we have a couple of core fundamentals, and I often find myself up on the stage with a lot of the other rocket CEOs, and I look down the stage, and generally I'm the only non-billionaire sitting on the stage. And the reality is, at Rocket Lab, we have no money, so we have to think, and we can't outspend our competitors. We just have to outthink them or outwork them. That's the only way we can be competitive, and that is really what is the foundation of the success of the company is sometimes too many resources makes you lazy.
Yeah, absolutely. In terms of what that means then for the kind of shape and look and feel of the overall market, I mentioned consolidation there. I just wonder whether...
So look, sorry, I didn't answer your question. The industry went, that was the beginning of the industry, and then there was a tremendous amount of money that flowed into the industry, and we saw things get funded that we were just sitting there scratching our heads over to values that didn't make sense either. And that's typical of any kind of almost bubble, if you will. But the one great thing about the space industry is that you can be very aspirational, which is awesome. But the other side of the coin is, at some point you have to deliver. And there's been a tremendous amount of aspiration in the industry and very, very little delivery. And I think what you're seeing right now is kind of the rubber's hitting the road. And a number of we just talk about launch to start with. A number of launch companies hit the wall, gone bankrupt, gone public, failed, carrying on. And so yes, ultimately, at the end of the day, you have to deliver, and it's very, 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 very difficult in this industry to deliver. It's very easy to talk about exciting things. We've really seen the separation from aspiration to delivery, and I think there's a bit more of that yet to come.
Yeah, fantastic. No, I wanted to drill down to that point because it does seem that a lot of those kind of weaker propositions have been cut away at this point. And I mean, there's focus on then two leading companies in terms of launch schedule. That's yourself and SpaceX. What do you think it is about you, Rocket Lab and SpaceX, that separates you from the rest of the industry, particularly in terms of your ability to launch at scale?
Yeah, and there's a number of things. Firstly, you need a product that works and that people want. So that's the kind of it sounds logical, but that's actually not that easy to deliver in this industry. And then you have to successfully scale that product. And I think Elon's on record in saying that actually scaling the Falcon 9, or in fact scaling any product, is like 100 times harder than building the first one, and this is absolutely true. As you can see from my background that we talked about in the beginning, I was a production design engineer developing production lines, so I know production well. And as we were developing the Electron rocket, we were developing it with the eye on production. So we didn't develop a product and then go, okay, now let's put it into production. That just doesn't work. So really, I think it's a unique mix of kind of skills and experiences, and bringing a product that people want to actually use, and the right product at the right time. And there was a lot of debate in the small launch industry about what was the right payload class, and we were very resolute with what we felt was the right class, and we were right, and that's great. And we're doing the same again with Neutron. There's always, when we announced that product, there was some debate about our selection of the payload size, and I think we'll be proven to be right there again. But but bringing the right product to the market at the right time, and then scaling it successfully are two things. I mean, we've seen a number of people bring a rocket to orbit once or twice or even just a few times. But where the real separator is like, okay, one or two that's actually not very impressive. But I can tell you that our 20th rocket was like at least 100 times harder to build than our first rocket, and we're approaching 50 now, and apart from SpaceX, as you point out, like nobody else is building and launching it at that frequency, and it takes, I reckon, it takes about 50 rockets before you start to get into even a groove. So yeah, that is, it's just a difficult thing.
Yeah, I mean, that's why I was keen to point out that I think it's an incredible kind of pace that you've been able to set. You talked there about a strategic decision. You've made two there, I suppose, about the payload size in relation to Electron, and then you've made a similar decision in relation to Neutron. How do you go about making those decisions? Because it's almost critical to the longevity of the company that those are the
Absolutely.
right ones. So,
Yeah,
so
yeah.
how talk us through that decision making process?
Yeah, I mean, look, I'd like to pretend that it's more complicated than it is, but it's not as complicated as, other than looking at all the payloads that require launch to what inclinations and what energies, and make understanding your customer's business as well. I think you can wish a whole lot of business without actually talking to your customers, and develop a product, but you know, ultimately you have to listen to what the market needs, and we have there's a bit more of a bet with Electron, because there was no small launch category and we kind of created it. But at the end of the day, it's just kind of a logical dissertation of what was out there at the time and what was predicted in the future. With Neutron, it's a little bit. I'd say we're in a much more luxurious position, because we have so many relationships with so many customers that they just told us this is what we need, and a lot of that largely converged. So there's some things that didn't converge that you have to make decisions around. Like, if I make the rocket 10% bigger, it might my operational costs might be 20% more, because I kind of flip over a threshold. So I'm going to forego 10% of the market to save 20% of the operational cost of the vehicle. So you have to kind of be sensible in the way you make these decisions. But I would say Neutron in almost every respect is having a do-over is significantly easier than the first one.
Okay, great. Yeah, no, that's really interesting. We'll come back to Neutron, but just to talk about the current applications of your technology, just to make some of this less abstract again for people less familiar with Rocket Lab. I think we had circa 2,500 satellites in low Earth orbit around 3-4 years ago. Today we have close to 10,000. I mentioned this just to get a sense of the main applications of your rocket technology today. What are all these satellites being used for predominantly?
Yeah, well, I think it kind of breaks up into a few different categories. I think the first one is communications. So we're starting to witness the rise of the broadband or internet from space, and there's a number of constellations and formation around the world that are coming together to service that market. We're right at the very beginning of direct to mobile. So once again, it's a communications platform, but direct to mobile applications. And then another big category is Earth observation, and then within Earth observation, it bifurcates into a number of different verticals as well. Well, obviously optical is one, and then synthetic aperture radar, and then RF, and so various things. But it all kind of boils down to looking at the planet and looking at things or people or changes on the planet, and then you have the sciences. So whether it be both Earth or interplanetary sciences, and you have applications like direct to dish TV and entertainment, and once again you could largely couple that into communications. And then other things like GPS. And I think the thing about the space industry is it's all hidden infrastructure. So you jump on your mobile phone and get an Uber. I guarantee you that nobody getting an Uber realizes that is totally enabled by the GPS constellation in orbit. I often joke, if you turn off the GPS constellation, the planet just about stops. Like, it'll literally be comical. You'll have ships driving into each other, planes flying around in circles, your Tinder date not knowing where to go, and it would just be carnage. So space is literally hidden infrastructure, but infrastructure that we absolutely rely on critically every day for just about everything we do.
Yeah, no, that's really interesting, and to pull out maybe a less scaled application, and one that's maybe less familiar with even those familiar with this industry at large. I think last year you delivered the first of 4 advanced spacecraft designed to facilitate in-space pharmaceutical manufacturing for a company called Varda. So it wasn't an application that I was aware of when I was reading about it. So perhaps you can just introduce to the listeners exactly what that is and how it works.
Yeah, so I mean, certain protein crystals, grow differently under 0G. You have 1G, 1 times Earth gravity acting on a crystal. It grows a certain way. You take away gravity, and it grows in a much more pure sense. The purity of those crystals is very interesting to pharmaceutical companies because they can make more effective drugs. And so that particular project, we developed and built a spacecraft. It's kind of like an on-orbit factory for our customer Varda, and then we held it in orbit and operated in orbit for a number of months. And then the real tricky thing is that we had to land it back in the Utah desert, the capsule, for them to recover the drugs. And there's only one other company that commercial company that's re-entered something and landed it safely back on Earth, and that's our friends over at SpaceX. So, once again, a very complex thing to do, but we don't do these things because we're trying to be cool. Every one of these projects is very strategic for us, and the reason why we did that project is that at some point in time we're going to have some astronauts aboard a Neutron capsule perhaps, and I'd much rather learn how to do re-entry on a pharmaceutical crystal than for the first time with astronauts aboard. So that project really taught us how to do precision re-entry, and that is a capability the company now has. Like, if you said to us, we want you to re-enter a human spaceflight capsule in the Pacific Ocean, we would just go, no worries. So everything we do is we do for a strategic reason.
Yeah, I mean, that's really interesting to hear. My next question was about whether that was an experiment aimed at kind of growing that as a properly scalable revenue channel moving forward, and whether you get a lot of demand for that type of product. But actually, was it more just that precision entry or re-entry point that you mentioned?
Yeah, I mean, we think that down mass is interesting, and we think what Varda was doing was an excellent approach, and we're very keen to support their growth. And as you pointed out, we have a number of these missions on the books, but that wouldn't be enough for us to do it. There has to be a strategic element of where we direct our engineering resources, and we're in a slightly fortunate position in the fact that we get to choose our work. We have so many opportunities presented to us that we have to really be careful about what we take on and how quickly we grow, because the most important thing at Rocket Lab, and you can ask anybody, it's you have to deliver, do what you say you're going to do. So we never want to get into a position where we don't deliver for our customers, because we'd certainly like to think, if you ask anybody in the industry what Rocket Lab stands for, and that is that our stuff is beautiful, our stuff works, and we deliver.
Yeah, absolutely. And on that point, then, in terms of generally delivering for customers, I wanted to dig into your your business model and generally the revenue channels and applications you see out there. We've discussed a couple of them already. I just wondered whether you get any sense of kind of comfort in respect to the maturity of some of these revenue channels when you look across at Amazon's Kuiper project. You've got SpaceX's Starlink. We talked about that earlier. Does that resonate at all?
Yeah, absolutely. So, I mean, like I say, I feel like an old soul in the industry, but I remember when a lot of these projects were talked about, and there was going to be thousands of satellites in orbit, and everyone's like, that's just crazy, there's never going to happen. And when you see like the Amazons and MDA Global Star. And Apple with their SOS platform now, and like you see real companies utilizing space in really important ways to them, that it's no longer science fiction, that the kind of democratization of space is going to occur. Like, it is unfolding as you see it. And I like in my short career, I've seen rockets go from purely a government program to now governments, especially the US government, especially there's less good examples around the rest of the world, but within the US, like there's only the SLS rocket that's owned by the government now. Like, everything else is commercial. So it's really it's really been space launch has been completely democratized in just a few short decades.
Yeah, absolutely. On government contracts then, or government applications even, your involvement or government involvement in general in any industry, I suppose, bolsters the total addressable market and the investment case if we're looking at it from an investment perspective as well. I did see the news of Rocket Lab's first National Reconnaissance Office mission from US soil. Just perhaps you can talk to us about the strategic significance of that launch achieved from your Launch Complex 2 in Virginia, I believe.
Yeah, look, we've actually had a very long relationship with the NRO. That was our fifth launch for the NRO. First launch, as you pointed out, first launch from US soil. We've launched the other 4 out of New Zealand, which is a really important partnership between the two countries as well. So they're a great customer. Probably the most discerning customer that you'll find. The stuff they're doing really matters. It really matters to the national security of not just the United States, but often the world. So as far as like the upper echelon of customers that you can fly, that's really it. I mean, they fly on SpaceX, ULA, and Rocket Lab, and that's it. So really. Tremendous responsibility to be trusted with such payloads.
Yeah, and your point there around kind of the discernment of a customer like that and the level of customer like that, you're clearing, I guess, sizable administrative security hurdles to work with and to have those government contracts on your books. As you say, it's not the first of these missions, but just talk to us generally about how difficult it is to overcome those hurdles or work with the companies or governments, to overcome them, and what that then means for the future of the business moving forward.
Yeah, I mean, we've been super lucky that we've seen really strong government uptake and belief in the company and in the product, and like I say, we all we care about is execution, right? And ultimately, that's all a customer cares about, especially a government customer. So yeah, I mean, it's a different working relationship with a government customer, especially a national security customer, than a commercial customer. A commercial customer just wants a thing. A government customer wants a thing, but wants to know how everything about that thing and how it was made, and tremendous amount of security aspects about that thing, and so on and so forth. And that's fine, but it is it's a different it's certainly a different beast. But so I don't see it so much as overcoming issues to work with the government. I think the government has leaned forward, very very clearly into kind of commercial space, and it's been our experience, if you create a great product, a thing or a service that is valuable, then they're very innovative and adaptive to try and use it.
Absolutely. Okay, well, let's turn our minds briefly then to your engineering approach. We haven't gotten into the detail of that, so perhaps we can do that here. Starting with launch, perhaps you can just give us at a high level why you've chosen carbon composites versus other materials.
Yeah, well, like I say, I kind of have a unique background in both metallics and composites, and a rocket is a giant engineering compromise. So you trade one thing against each other all of the time. And as an engineer, it drives you insane, because in engineers, you're always striving for perfection in every system and in every component and every structure and every material. But that just doesn't exist. So, you often find yourself sitting in the corner rocking backwards and forwards in total frustration. But the reality is that, the lighter the structure you can make, or the lighter everything you can make, the more goodness you will have. And we call it the spiral of doom at Rocket Lab. So if you add, say, a kg of mass to a rocket, then you have to add 10 kgs of propellant to lift that kg of mass. But the reality is, to hold those 10 kgs of propellant, you need to add another kg of tank to lift that extra 10 kgs of propellant. So then you need to add another 10 kgs of propellant to lift that extra kg of tank mass. And then on it goes. And you just end up with a rocket that just has negative performance. Because the reality is that somewhere between 1 and 5% of the total rocket's mass is actually the payload you put into orbit. So if you're a fraction of a percent out on anything, you just end up in the spiral of doom. So if you can reverse the spiral of doom and say, well, my tank did weigh 10, per unit length of tank used to weigh 10 kgs, now it weighs 9. That means I can take out like a bunch of propellant, and then I take out a bunch of propellant, I don't need so much tank, and it starts shrinking. So using a material, this is a very long-winded answer to your question, so I apologize, but if you can use a material that's just fundamentally lighter and stronger than traditional metallics in the first place, then you get to spend mass in other areas. So no more is this true with Neutron, is that Neutron is a very large carbon composite rocket, very large. The largest, some of the largest carbon composite structures produced. But the reason why we do that is that we save so much mass in that structure that all of a sudden our propulsion system or our engines don't have to be so highly stressed. And in a reusable rocket, the thing that you want just kind of idling and not screaming is your engines. So we, once again, giant engineering trade and compromise, but it's the lighter that you can make your structures, the better starting point you have. And a carbon composite structure is the strength of steel, but 4 times as light, or a quarter of the weight.
Yeah, fascinating. I can see how you can quite quickly end up in that spiral of doom, and working your way out of that could be mind-bending to a certain extent. I mean, you mentioned Neutron there. I meant to ask it earlier, but that competes more directly with Falcon 9 and SpaceX, whereas in the past you focused on smaller rockets, as we've already described. So you listen to your customers. That's what they wanted. But to what extent is this a more crowded market, and how does the product aim to differentiate from the other products that exist elsewhere?
Yeah, I mean, yes, it's unashamedly a competitor to a Falcon 9. The Falcon 9 is an amazing vehicle, and it's created. It's right now it's arguably a monopoly, and that's fine. But there's very few examples in history where monopolies persist. And we have an advantage where, or a couple of unique advantage points is one, we've learned everything we needed to learn on a small rocket, including reusability, because we cut our teeth on reusability for Electron. So we've learned a whole bunch of really expensive and hard lessons on that vehicle, which when you go to apply to a larger vehicle, save you a lot of time and effort and energy. So there's that sense. The other thing to remember is that with a small rocket is by far the hardest rocket to build. And I can put my hand in my heart and I can say that because we're built a small one, now we're building a big one. And the reason why it's so hard is that there's so many things on a small rocket that don't scale. So a quality control organization, they don't care if you're building a 12-inch valve or a 2-inch valve. It doesn't matter the size of the valve. It's the same size organization. Now, where that becomes challenging is that you have to have these organizations. You have to have flight safety teams, and you have to have supply quality teams, and you have to have your own internal quality teams, and so on and so forth. But with a small rocket, you have in the case of Electron, it's sort of call it a $7.58 million sticker price. So, you can't have a 50-person quality team amortized over an $8 million sticker price. You can easily do that over a $55 million sticker price. But nevertheless, none of those teams or functions or capabilities care what size your rocket is. You still have to provide that service or have them. So we have been forced to innovate, innovate to fit all of those functions and all of those things and build a reliable product and a manufacturable product into a sticker price of $8 million. So when we look at a Neutron sticker price, call it $55 million, it's like luxury. I've never had so much margin to do stuff before. So how we think we're going to be competitive in this marketplace as well. Firstly, we have been created an organization that is just so lean and so efficient that when you apply that to a much larger scale, then it's just awesome. And then we've had all the advantages of both our learnings and, quite frankly, their learnings to build a vehicle which it looks very different from any other rocket. And that's not because we're trying to be different. It's because we're applying all of those lessons, combined, that have been learned to a new vehicle and a new vehicle design, which we think is going to be extremely efficient.
Yeah, fascinating. No, I'm glad we went back to that question, because that was something I think a lot of listeners would have been keen to hear. But no, that makes complete sense. I think to finish, then, it makes sense to turn our minds to what's next. I guess in your bid to build a long-lasting space company, a company with real longevity, I discussed with Colin actually your concept of space as a service, or the result of vertical integration strategy, enabling this new kind of SaaS or provision of direct to customer capabilities. So perhaps for anyone that hasn't heard it, just give us a sense of what the vision is there.
Yeah. Look, I'm sorry, I've monopolized this conversation around rockets. It tends to happen, but actually, two-thirds of our revenue as a company comes from our space systems division. So rockets are the enabling keys to space, but actually, two-thirds of the company's revenue is actually from our spacecraft and spacecraft systems, and that kind of comes to the point of your question is like. My view of the large successful space companies of the future is not a rocket company, a standalone rocket company, or a standalone spacecraft company. When you combine both a rocket company and a spacecraft company together, you have the keys to space and you have the ability to build any infrastructure in it. At that point, it's really a question is what service are you going to provide from space? So where Rocket Lab is ultimately going here, albeit very methodically, is ultimately we want to just provide services from space. And we're kind of at a really interesting inflection point where customers are coming to us now and asking not about what is how many kilowatts are the solar panels you can provide us, or how many newton meters of torque do your reaction wheels produce, or what's the payload of Neutron? And no, they're coming to us and saying, I want to do this thing on Earth. I think it can be done from space. I don't know anything about satellites, and quite frankly, I don't want to know anything about satellites and all of the operational constraints that go with them. I just want to provide this service on the ground. Can you do it? And so that's ultimately, I think, where all the large space companies will drive to is like, to be a competitive, successful, large space company, you have to have your own rocket. You have to have the keys to space, and you have to be able to build whatever infrastructure you need to build. And then really it's just a question of, what services are you going to provide for whom.
Yeah, great. I mean, then to join this point and this part of the conversation with the engineering one, I think I heard you describe on an interview, potentially with Forbes, how the industry maxed out on combustion efficiency, chemical compulsion, materials, etc., a long time ago. So as a result, we're seeing Elon just building bigger and bigger rockets.
Yeah, it's all that's left to do.
Yeah, right. But is your view in terms of what's next and what is left to do from Rocket Lab's perspective, this end-to-end D2C offering?
Yeah, I think that is I mean, that example, I guess, is it was purely on the rocket equation side. Like, we've reached chemical equilibrium. We're at 98% C-star combustion efficiency. There's nothing more for the chemicals to yield. So unless there's a step change in like the way we propel stuff, then other than just burning things, then your only option is to just build a bigger and bigger rocket, get the cost per kilogram lower and lower. That's the only option. But that's on the rocket side of the equation. But yes, I think kind of more holistically, if you just treat rockets as the keys to space, more holistically, actually yes, at least in my eyes, that the logical, devolution, if you want to call it that, of what all this ends up as is just putting infrastructure and services in orbit and being that end to end. Because the space industry is best described as like a whole bunch of man pass shops all at subscale. So if you want to do anything in scale and space, it's just really difficult. And as we've talked about in this conversation, no matter what, like, your biggest competitor in the space industry is physics. And everything you do is an engineering compromise. So the satellite that you put on the rocket is compromised against the G forces or the G loading of the rocket, and vice versa. So if you can start to make that a little bit blurry, the rocket looks a bit like a satellite, the satellite looks a bit like a rocket, and they're sort of built in tandem together, then that's when you can extract real advantage.
Yeah, absolutely. Okay, well, I want to finish on two questions. The first is just to think about the ultimate scale and total addressable market within this space. I mean, market projections are testament to the unknowns here. I think projecting will hit anywhere between 1 and 2 trillion in terms of TAM. Do you think, I mean, maybe back to that kind of SaaS D2C model point, is that the thing that starts to justify even the low or high end of those projections? And if not that, what else do you think can start to feed into that TAM?
Yeah, I think it's exactly right. Like, if you look at the TAM as it stands today across the industry, call it somewhere between $10 and $20 billion of the space TAM is launch. Somewhere between $20 and $40 billion is satellites or space infrastructure. Over 350 billion of the TAM is exactly as you say, like the services that you use down on Earth that come from space. So if you're just a brutally logical person and you stand back and you look at the space industry, and there's 3 buckets of TAM that you want to play in, naturally you point to the big one. But the challenge is that to get to the big one, you kind of have to jump through the hoops of the first 2. And so that is it's just a pain that it's so difficult to get into space and then operate there. Otherwise, this would be easy. But the reality is there's no free lunch, and at the end of the day, it's like I mentioned before, like the biggest competitor in this industry is physics.
Yeah, yeah, absolutely. Well, I want to finish on a question then that we ask all of our guests. You've been really great with your time, so I just want to make sure we get this one in. It's the same question that we ask all of our guests. We speak to company founders, specialists from different themes and industries as well. And we ask all of them to leave listeners with one takeaway, perhaps an exciting application that's yet to go properly mainstream. What's your next big idea within the space industry at large?
Well, firstly, I'd think it would be both commercially silly and probably slightly illegal if I disclose non-public information. I think so. I'll be restrained in my view. But what I will say is, look, the biggest idea to happen into space has not been thought of yet. Like we are such at the beginning of the democratization or the commercialization, however you want to say it, of the industry. Like, you know, call it 3 decades ago, we were all just standing in front of giant, government rockets that launched a few times a year. Like this is the beginning of such a massive industry, and it's a little bit almost like the internet. Like you think the internet was email was going to be the thing for the internet was email, but who could have thought of all of the the crazy things that occurred after that? And I think we are literally opening an entirely new domain. It's like standing on the shores of a beach, and all of a sudden there's boats. So that's kind of where we're at. So I think not to be too waffly, but I truly believe that the biggest application is yet to be thought of, let alone executed.
Yeah, no, absolutely, and not waffly at all. I think that's a fantastic point to finish on and something to look out for listeners moving forward. I think that just leaves me to say thank you very much, Peter, for joining me on the podcast. Been a real pleasure.
My pleasure, Hayden. Thanks very much.